Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we are in lecture number 37 in our dynamics class 61211. Today we are going to cover the last chapter that we cover in this class, which is vibrations. So now what is our purpose in this chapter is to cover undamped single degree of freedom vibration of a rigid body. So we will be looking only at single degree of freedom. We will not exceed that in our class. We'll start with undamped vibrations. So we need to define what do we mean by vibrations, and what are the types of vibrations that we are going to cover. Vibration is the periodic motion of a body or a system of bodies displaced from a position of equilibrium. So the vibration is the type of motion in which you have some type of periodic motion. So the motion is going to be periodic. It goes back and forth around a position of equilibrium. So initially the body is going to be at a position of equilibrium, and then it starts moving and vibrating. شو معنى vibrating في العربي؟ ممكن نقول اهتزاز فيها. Okay. So it's vibrating around a position of equilibrium. So we got a position of equilibrium, and the motion is going to be what we call it a periodic motion. So it changes with time, and it goes around a position of equilibrium. There are several types of vibrations that we can talk about. The first type of vibration, and that's what we concentrate on, is free vibrations. Free vibrations are those motions which are maintained by conservative forces like gravitational or elastic restoring forces. So to have a periodic motion for a rigid body, you need a force to cause that periodic motion. We call the vibration to be free vibrations if the force which causes the vibrations is a conservative force, similar to the gravitational force or to the elastic force. إذا القوة اللي بتعمل الفايبريشنز هي conservative force مثل الجرافيتيشنال فورس أو spring force elastic force، هون بنسمي الفايبريشن free vibration، فايبريشن حر. الجرافيتيشنال فايبريشن مثل pendulum، it's similar to the pendulum. لما يكون عندك بندول الساعة بضل رايح راجع. So the pendulum goes back and forth. What maintains the motion is the gravitational force, because gravitation is a conservative force. You have the total energy is going to be constant. So T plus V is equal to constant. The kinetic energy plus the potential energy is going to be constant. So the potential energy will transfer into kinetic energy. The kinetic energy will transfer into potential energy, and vice versa. And that would maintain some type of a free vibration. The elastic forces, when you have a spring, you have, let's say, a body connected to a spring. You start the motion. So the elastic potential or the elastic force is a conservative force. So you will have the elastic potential plus the kinetic energy would be constant. So the body would be vibrating around a position of equilibrium when you have a particle connected with a spring. Force vibrations are motion caused by external periodic or intermittent forces. Now we can cause vibration but by an external force. If you have a force and that force is periodic، إذا كان عندنا قوة بتسبب الحركة وهذه القوة هي عبارة عن periodic force، يعني بتروح وبتيجي. You can describe it by a sine wave for example. إذا شو بتصير الحركة؟ بتصير vibrating motion. هلا هذه this type of motion or this type of vibration we call it forced vibration, because it is caused by some type of a force. The force by itself is either periodic force or intermittent force. Intermittent force, so the force would apply and stop. You can get some type of vibration with that type of force. So what we will do is we are going to start with the free vibrations. Later on we will move to forced vibrations. Now there is another difference between vibrations. We can say undamped vibrations and damped vibrations. Undamped vibrations are those vibrations which continue indefinitely. So we call the vibration to be undamped if the vibration continues forever, does not stop. And when does that happen? If we neglect friction forces. إذا بنهمل قوة الاحتكاك شو بصير في الفايبريشنز؟ بتستمر إلى ما لا نهاية. فهذا البندول, the pendulum that you have, if you neglect the friction at the hinge, at the bend connection of the pendule, then the vibration is going to continue indefinitely. Now if you consider friction, then the vibration are going to be dammed out with time. So they are going to stop with time. فإذا الفايبريشن, if we neglect friction, continue indefinitely, بضلهم مستمرين, فهون بنسميه undamped vibration. If we consider friction, then the vibration will become damped vibration. So here, damped vibration when external friction forces are present and considered. So what we will do in this chapter, we will start first with free undamped vibrations. So we will look at vibrations which are free, caused either by gravitational force or by elastic forces, and we neglect friction. Then we will move to forced vibrations and see if we have a body and we have some type of a periodic force, and we want to describe the equation of motion for that condition. Then after that, we want to consider friction, or we want to consider resistance and model the friction force, and let's say study the damped vibrations. So this is how we'll do. Today we'll cover three vibrations. We will use the equation of force and acceleration to describe three undamped vibrations. Next week we will use the principle of energy to describe three undamped vibrations. Then later on in the week we will move to forced vibrations, and by the end of next week, inshallah, we will cover damped vibration. The easiest, okay, and again, all of vibrations that we are going to talk about, single degree of freedom. Single degree of freedom. درجة واحدة من الحرية. إذا معناته بدي يكون عندنا. Okay, the simplest vibrations that we are going to consider or think of is a block connected to a spring. Now the spring will have an elasticity K, and here is a block. Now we want to neglect friction between the block and the surface. If you consider friction, then it will become damped vibration. What we want to do is neglect a friction. So initially, if the block is attached to the spring and the spring is unstretched, we have no motion. مظبوط؟ في البداية, if you have, here is your spring and this is the block. If the spring is unstretched, you have no motion. Suppose that somebody pulled the block or gave the block an initial displacement or an initial velocity. So what is going to happen? The block is going to move back and forth, back and forth. So what we will have is periodic motion. Now to describe this periodic motion, what we will do, we want to write the equation of motion for this block. We always take the distance or the displacement from the position of equilibrium. So let's assume that here is the unstretched length of the spring. So this is our initial, or this is the unstretched length, unstretched length of the spring. L unstretched. So initially, at this position, the block is not going to, okay. Initially, if there are no forces, nothing, the spring is unstretched, the block would be here. Now somebody pulled the block or gave it an initial velocity, so it's going to be moving back and forth. At any point in time, what we will do is we want to write the equation of motion for this block. So at any point in time, the block is going to be a distance x from the position of equilibrium. في أي لحظة من الوقت مش بتكون البلوك بتكون على مسافة x من ال position of equilibrium. So at any time, the block is going to be a distance x from equilibrium. Now x In this direction is positive. In this direction is going to be negative. Okay, at this moment, when this block or this spring is stretched a distance x, what are the forces acting on the block? What we will have? We have the weight, we have the normal reaction, and we have here كيف x. شيك؟ فالقوة اللي مؤثرة في عندنا كيف x in this direction. We have the weight, we have the normal reaction. And what's there? The block is going to have an acceleration. And we want to take this to be positive. To the right direction is positive. So our acceleration is going to be A to the right. Okay, if it becomes negative, that means it's to the left. So the kinetic force that we have is M times A. Now in this situation, if we want to write the equation of motion, in the y direction, just the normal reaction equals the weight. There's nothing new in that. In the x direction, what's going to have? Summation of f x equal max. Check. Summation fx minus fx equal m times ax, or m times x to dot. مش هيك? What is the acceleration? The second derivative of x with respect to time. So if you take it to this side, you will have m x to dot plus fx equal to 0. Oh, sorry, k. I am sorry. This is k. So summation fx equal max. The force in the x direction is kx. So minus kx equal max. Or minus kx equal mx to dot. Now put both of them on the same side, you'll get that mx to dot plus kx equal to 0. So that is our equation of motion. What's going to happen is when we take take x to be the displacement from the equilibrium position, you will get that m times ax, which is 2d2x by dt square equal minus kx. Move it to the other side, you will get that m d2x by dt square plus kx equal to 0. Divide by k, you will get this equation. So this equation is actually x2 dot plus k over m x equal to 0. So here, okay, we have here m x2 dot plus k x equal 0. Divide by m. شو بصير في عندك؟ x2 dot أو d2x by dt square plus k over m x equal to 0. What is this? What is this? This is a differential equation. This is a differential equation. What type of differential equation? It's a linear, homogeneous, second order differential equation. So what we have here is a linear, homogeneous, second order differential equation. Now if you study differential equations, you know how to solve this equation. However, for us, we give you the solution. Okay? The solution for this type of equation, look here. You have x2 dot plus k over m. K over m is positive. K over m is positive. We can put, instead of k over m, some type of omega square n times x. Because k over, so omega n here, it's going to be square root of k over m. Omega n is square root of k over m. So what we need to do is to be able to write the differential equation for motion. Now the differential equation is for a free, undamped vibration is going to come in this form, regardless what type of motion you have, whether it is pendulum, a block moving by a spring, or whatever. What we end up with, a linear, second order homogeneous differential equation. This equation is going to be in this form. x2 dot plus k over m x equals 0. Now here, sometimes you get something different than k over m, depending on your equation. So instead of putting k over m, I want to take the square root of it, so it would become omega n square x, because this should be positive. If you write the differential equation right, it would be positive. This is a second order differential equation. Its solution is in this form. X equal a sine omega n t plus b cosine omega n t. Now you can prove that this is a solution. How can we prove that? Just take x dot, x2 dot, and come here. Substitute in this equation, you get the answer to be 0. So the form, the solution for this equation is a sine wave plus a cosine wave. But the sine wave should be multiplied by a constant a, and the cosine wave should be multiplied by a constant b. How can we find a and b? A and b are usually found from the initial conditions. At time 0, we can find, or from knowing the conditions, at time 0, we can find a and b. So what we need from you in this chapter, or for this section, for undamped free vibrations, is to go back here to the position of equilibrium, displace the body a distance x from the position of equilibrium, and write the equation of motion. Now for the equation of motion, you need to play around with the equation of motion until you modify it to become in this shape, which is a homogeneous second order linear differential equations. When you get to this form, then the solution is going to be in this form. Now to find a and b, we can find them from the initial conditions. Omega n, in this case, is going to be square root of k over m. Let's look at this solution. We are saying that x equal a sine omega nt plus b cosine omega nt. This is a sine wave plus a cosine wave. If we draw this solution, this is the shape that you get. Here is time, and up here is distance. At time 0, if we put t equals 0, a sine 0 is 0. What you will get? B cosine 0 is b. So this height here is going to be b. So what is b? B is going to be x naught at time 0, or the initial displacement to the spring at time 0. So when you start the vibration motion, what you do is you pull the block a distance x naught. انت بتجر البلوك تبعتك مسافة 10 ملم مثلا whatever x naught, وبتعطيه v naught. مش هيك you start the motion؟ مش هذا initially the body is connected to the spring and there's no motion. You start the motion. How you start the motion? You give it an initial distance and initial velocity. The initial distance could be 0, or the initial velocity could be 0, but you got to give it an initial motion. So if you pull it initially by a distance x naught, then the coefficient b is going to be actually that distance. Now if we want, or b is going to be x naught. To find a, we got to look at the velocity, so derive this. But we need to look at this shape of curve. If you look at this height, what is this height? This is the amplitude. مش هذا طول الموجة، ارتفاع الموجة. If we have a sine wave and a cosine wave in this shape, what is the height? Square root of a square plus b square. This is going to be square root of a square plus b square. مش هيك؟ ارتفاع الموجة هو عبارة عن ايه؟ square root of a square plus b square. ربع حادي شو بصير؟ ساين سكوير بلس كوساين سكوير 1. شو بيطلع عندك؟ a سكوير بلس b سكوير هو عبارة عن ارتفاع الموجة. إذن the shape, the equation of motion, or the x is going to be given in this format. The height, or what does this height mean? شو معنى هذا الارتفاع؟ or the amplitude عبارة عن إيش؟ It's the maximum displacement. It's maximum x. هذا هو عبارة عن الماكسيمم ديسبليسمنت اللي بتصير للبلوك تبعي. في الاتجاه الثاني شو بعطيني؟ المينيمم ديسبليسمنت or x max but in the negative direction. فهذا بعطيني أكبر مسافة بدها تمشيها البلوك على الشمال، أو أكبر مسافة البلوك بدها ترجعها على اليمين. طبعا هذا هون الزمن has some type of importance. هذا هو عبارة عن إيه؟ هو زمن الدورة. Okay. هذا هو عبارة عن زمن الدورة. It's the time for a complete rotation. الزمن اللازم حتى إنه البلوك شو تعمل دورة كاملة، تبدأ من نقطة وتروح وترجع لحد النقطة تبعتنا. فهذا هو natural period of vibrations في الواقع بنعرفها.
عرفنا أول إزاحة بتكون للجسم إيه؟
أوكي خلينا نشوف هون. أوكي إذا إحنا what we are talking about undamped free vibration. This undamped free vibration is going to be defined by omega n, which is square root of k over m. What is omega n? في الواقع omega n we call it the natural circular frequency of vibration. هي عبارة عن natural frequency of vibration. Natural circular frequency of vibration is omega n. In the case of the spring, it's going to be square root of k over m. So in any question you are asked, usually you need to define omega n. So you write the differential equation of motion and calculate omega n. After you calculate omega n, the next thing to calculate is the natural period of vibration. Natural period of vibration هي عبارة عن الزمن اللازم حتى يصير في عندنا full circle of vibration. Tn is given by 2 pi over omega n. ليش as a 2 pi over omega n? If you go by, what do you want this to be? 2 pi. مش هيك؟ Omega n times t for a full period should be equal to pi. So t is 2 pi over omega n to give you this time. So this time is 2 pi over omega n. الزمن حتى يصير عندنا دورة، إذا هذه شو بدي إياها تعمل 380 درجة. But here we use radians. إذا we want this to be 2 pi. So omega n times t, or tau, the natural period of vibration, should equal to 2 pi. So tau should be equal to 2 pi over omega n. So the second thing that you need to define is the natural period of vibration, 2 pi over omega n. Then the natural frequency. Natural frequency, what is the natural frequency? Is 1 over tau, or 1 over the period of vibration. Or we usually describe it in hertz cycles per second. So we need to find the natural frequency 1 over Tn, or it's going to be omega n over 2 pi. That's what gives us the natural frequency. Now, for finding A and B, what do? Is we look at the initial conditions. Okay, again, omega n is not function of initial conditions. It depends on the system. omega n بتعتمد على النظام تبعي، ما لها علاقة في الانيشال بوزيشن. لاحظنا اوميجا ان شو كانت سكوير روت اوف كي اوفر ام. على ايش اعتمدت؟ اعتمدت على كي واعتمدت على ام. اعتمدت على ستيفنس تبعت الزنبرك وعلى الكتلة اللي بدها تمشي. فكانت سكوير روت اوف كي اوفر ام. So omega n was independent of the initial positions, regardless to the initial positions. The natural period of vibrations has nothing to do with the initial conditions of the system. It's a property for the system. Natural period of vibration هي صفة من صفات النظام تبعنا. كيف النظام بيكون؟ شو الستيفنس تبعته؟ شو الكتل تبعته؟ هو اللي بحدد لنا اوميجا ان. Not the initial conditions. So we can ask you about omega n without saying anything about the initial conditions. It has nothing to do with the initial conditions. The initial conditions will define A and B. Will define A and B. A and B will define the height of the wave and where would the wave start at time 0. مش هيك؟ اوكي هلا بالنسبة for B x at time equal 0 equal x naught equal B مباشرة. To find V شو بنعمل؟ derive this. So V equal A omega n cosine omega naught t. مش هيك؟ شو مشتقة الساين؟ كوساين ناقص. شو مشتقة الكوساين؟ ساين. إذا B اوميجا n ساين اوميجا نوت t. مش هذا الفيلوسيتي؟ x dot. So x dot is minus A omega n cosine omega n t plus B omega n sine omega n t. At time 0, what is the velocity? We usually know the velocity equal to V naught. It's going to be omega. هذه هون زائد هون ناقص. مشتقة الساين كوساين مشتقة الكوساين minus ساين. غلطونا. Okay. So at time t naught, at time t0, when the motion starts, we have that the velocity is going to be V naught. And V naught is going to be an omega n cosine 0. Cosine 0 is 1. So V naught equal A omega n. So A is going to be V naught over omega n. So what we can do is we can write the equation of motion to be x equal x naught cosine omega n t plus V naught over omega naught sine omega n t. بدل B نحط x naught بدل A شو بدنا نحط V naught over omega n t. So this is the equation of motion that we have. Now if you start, if x naught equals 0, شو بتصفي equation V naught over omega n sine omega n t. So it would be a sine wave. If V naught equals 0, you will have only a cosine wave. Okay? بتطلع, when you look at this equation, it's cosine plus sine. We usually can modify this equation to make it just a sine wave instead of having it to be cosine and sine. And let's see how can we do that. So our equation is x equal A sine omega n t plus B cosine omega n t. What we can do, we can write it in the form of C sine omega n t plus phi. Phi is a phase angle actually, is a shift for the sine wave. C is the height of the sine wave. So instead of describing this to be, okay, what is the cosine? Isn't the cosine is shifting the sine wave pi over 2? مش هيك؟ الساين ويف الكوساين ويف مش هي عبارة عن ساين ويف بس لها شيفتنج بمقدار 90 درجة؟ صح؟ فإذا أنا في عندنا ساين ويف وفي عندنا الكوساين ويف هي عبارة عن ساين ويف صار لها شيفتنج درجة 90 درجة. شو بدي أبدلهن التنتين؟ في ساين ويف واحدة بس الشيفتنج شو بده يكون؟ زاوية فاي مش 90. لأنه إذا بدي أبدل الكوساين كلها في ساين ماشي بزيحها 90 بس أنا في عندنا ساين وكوساين. هذول التنتين two waves we can replace them just by one wave which is sine omega nt plus phi. Phi is the shift angle. You can derive this by the way. We can derive this. هذه okay, I don't like to derive all of these equations but x equals C sine omega nt plus phi equal sine two angles مش ساين الأولى في كوساين الثانية زائد كوساين الأولى في كوساين الثانية equal C sine omega naught t cosine phi plus C cosine omega naught T sin phi. مش هيك؟ Now C cosine phi مش constant، هو عبارة عن ايش؟ وهي عندنا sin omega naught، هو عبارة عن A. C sin phi مش هو constant وهو عبارة عن B. في الواقع انه A هي عبارة عن C cosine phi و B هي عبارة عن C sin phi. phi هذه بنعبر عنها هي عبارة عن phase angle. phi بتكون عبارة عن sin inverse of x naught over C or sin inverse of A over C. C is the height.
باي بي على سي مش
phi هي sin inverse of x naught over C
او بي على سي
أو B على C. أوكي، لأنه B راح تكون هي عبارة عن x naught. So C is the height of our wave, and C is still square root of A square over B square. So what we can do is we can write this equation in this form and write it to be x equal C sine omega naught plus phi. At time equal, if we want to derive the velocity is going to be C omega n cosine omega naught T plus phi. So at time 0, x equal x naught. So x naught equals C sine phi. At time 0, V equal V naught. So V naught equals C omega n cosine phi. So phi from this equation is going to be sine inverse of x naught over C. C is going to be square root of A square plus B square, which is the height of the wave. So now when we write the equation in this form شو بصير الحل أو رسمة الإيكويشن تبعتنا أريح. هذه لما بدك تيجي ترسمها when you try to draw this. Okay, I want to x equal E C sine omega naught T plus phi. هذا اللي بدي أرسمه. At time 0 شو بتكون x equal C sine phi. So this height is C sine phi, or إذا بترجع على المعادلة الأصلية شو طلع معنا هذا؟ هو عبارة عن B. أوكي، ارتفاع الموجة شو هو؟ phi. هذه الموجة صار لها عملية shifting بمقدار phi. ففي الكهرباء شو بتسموا phi؟ هي الفيز angle. How much you move your sine wave. نعم.
ارتفاع الموجة سي مش بي.
ارتفاع الموجة C or square root of A square plus B square. ارتفاع الموجة هو A square root of A square plus B square equal to C. هذا اللي بيعبر لي على الماكسيمم displacement اللي بتصير في عندنا. فإذا أنا I can represent the displacement with this sine wave. Just I make shifting for the sine wave. Now the period of vibration tau is going to be 2 pi over omega n. The same thing. The period of vibration is not going to change. لأنه هون شو بدي هذا المقدار يلف 90 درجة 180 درجة. طبعا phi is constant, does not affect the natural period of vibration. So we need that omega n times t equal to pi. So t equal to pi over omega n. So this is an easier way to represent the solution for this differential equation. Instead of using a sine plus a cosine, we can just use a sine wave. So procedure for analysis, what we need to do is you need to draw a free body diagram for the body when it is displaced a small amount from equilibrium position. دائما we need to look at the position of equilibrium. انه لما يصير في عندنا equilibrium في اتزان ونقيس دائما from the position of equilibrium. فالريفرنس فريم axis تبعنا بده يكون from the position of equilibrium. From the position of equilibrium we assume that the body has moved has been displaced a distance x or an angle theta, and we make a free body diagram for that body, and we write the equation of motion. The equation of motion, we should work the equation of motion until we get this form: x2 dot plus omega square x equals 0. طبعا لما تطلع omega n square نحل السؤال, and that is the circular frequency. So you need to apply the equations of motion, work with them out until you get this form. Hon, you need to get, it should be positive. So the coefficient of x is going to be equal to omega n. You need to get linear, homogeneous, second order differential equations. There should be no constants outside here. لازم تطلع معك المعادلة x2 dot plus omega n square x equal 0. غير هيك معناته بتكون غلطان. المرة الجاي بنحل, next time we will be able to solve problems like this.